So what are XML files? XML files are basically are files which you use to create your model and then for visualization. And so what we'll do is we'll, in this whole class, we'll basically run simulate, and then we will run the files from this model folder. You'll see. So I'll show you how to do that. And then we'll exclusively work with this example provided in MuJoCo. It's called hello.xml. It's in the model folder. So I'll copy paste in this XML folder and then edit it and show you how things change and what it looks like. And then when we do this, we'll extensively refer to the documentation on this link. Now that's really hard. Let me just, it's hard to type. So let me just copy paste that in the chat. But if you go to MuJoCo website, then, and if you type XML reference, you should see this link. So let me send this in the chat. So I suggest that you bookmark this page so that way you can open it anytime you want. When you go over here, you can click on XML reference. Okay? And when you click XML reference, that's the documentation we'll be using. Okay, so that's the first thing. You want to bookmark this page and keep it ready. Okay, so now here's how to run it. Now in the past, you did simulate and then you give the path of the model file. You really don't need to do that. This is what you can do. So go to the bin folder. Okay, and you won't have to change this because we'll only work through bin today. So once in the bin folder of the MuJoCo distribution, just type simulate. This is for Mac and Unix. For Windows, it will just be simulate, right? Without any dot. That's it. So once you press enter, you should see a screen without anything there. And this is where you can actually drop the file. So take the hello.xml and drag and drop it. So just drop it. Now what we'll do is we basically modify this hello.xml. And that's what pretty much the first exercise is. So open it. Okay, now you might want to open it in Atom because it gives nice indentation. So if it opens in text on your end, then what you can do is you can right click and then you say for your computer, depending on your OS, it will tell you application. So you can choose a different application, choose Atom, and then open it in that. If you don't have Atom, that's fine. You can open it in text. WordPad is fine, or even rich text editor is fine. Okay, so we'll just modify this. I think some of these things are sort of self-explanatory in terms, if you see RGBA, some of them are not. So let's go through this. So MuJoCo, by the way, this is the model and visualization stuff in MuJoCo. So you always tell the file that you're running with a MuJoCo environment. And so that's why you put MuJoCo and you end the MuJoCo. This is just ending the one thing you started. It starts with a it has a backslash, as you can see. Similarly, there's something called a world body, the world frame under which everything is going to rest. So that also has to be ended by putting a backslash like this. And then there are things about light, which, by the way, you can modify these numbers and see the effect. There is the geometry. It's called plane. This plane is actually the ground, which you saw here. It's the red thing, and we can check that. I'll check that in a bit. And then we have joint. So joint here, it says free, which means that this body, which is given by this keyword, is free. It has 6 degrees of freedom, can move in the X, Y, Z direction and rotate about the X, Y, Z axis. This body, we decided to be a box of dimensions of 0.1, 0.2, 0.3. So this X, Y, Z, and then there's an RGBA. So now if you want to modify things, like, for example, let's start off with the color. RGB is the color, and A is, I think, the opacity. We'll just change the color. So let's invert these things. So this is the value for R, this is the value for G, green, and this is the value for B, blue. And then 1 is the opacity. 1 means fully opaque, 0 means transparent. So let's not modify the 1, but let's swap this out. Let's just make this 0, and then make this 0.9. Right, so this now from red, it will become green. The plane will become green. And then let's change this from 0.9 to 0.90. Okay, so that becomes red now. So if we reload this file, then it should say that the colors are swapped. Now what you can do is, you don't need to kill this. If you want to kill it, by the way, you just press Control C, okay, on a Mac as well as on a Windows. But you don't really need to do that. What you can do is, first of all, save this hello.xml, go back to the hello.xml file, and just drag drop it again. So just drop it. So you can see that the colors inverted, so, which is not at all surprising because we actually didn't. Right? So just drag, drop. Okay, so this is what we'll be doing in the remaining 15-20 minutes. We will be modifying this file, just drag and drop it. And if there is an error, then you'll see the error popping up on this bin window. Okay, it'll tell you what the error is. So for example, if I get rid of this slash, okay, and then I go and I just drop it, you see nothing happened. In fact, if you go to the MuJoCo window, it tells you that there was an error. So it says error reading end tag at line 9, column 5. So line 9 is right here. Oh, interesting. It says line 9, but actually the error is at line 8. Okay. Put it back. It should run fine. Okay. Okay, so now let's start doing more modifications to this file. As I said, we look at the documentation. Let's look at MGCF reference. The first thing I would like to try to do is, why drop this file, this block in the vertical? Well, why keep it at the angle which it? Let's just rotate that angle by a certain angle. So if you want to rotate it, we want to change the attribute of the body. What is the body? Well, it's right here. Where is that? Okay, so right here in body, we've set the position, right? It's 0, 0, 1, which means that X, Y is 0, the Z is 1. That's why it was at a certain height, that is 1 meter from the floor. Now we want to also change the, let's say, the orientation of the body. So let's see if we can find something which helps us change the orientation over here. So we're searching for body here. There are two places to find this. One is if once you're in XML reference, is where you are, you can open the MGCF reference, and then you see a bunch of options. The other place to find it is just right below XML reference. You'll see that there are all these options. Okay. So these are basically the options which figure out here. So for example, MuJoCo is one of the options which you saw was right there. So that's one. Then you can try to search for other ones. So for example, there is joint, that's joint. Okay, so this basically gives you a summary of the option and what those options within joint, what type of things you can define within joint. And then if you want more details about this, that's where you go for this. So if you scroll all the way down, it's basically in here. So include MuJoCo, what you can say, what you can't say. So either you can scroll it or you can just go here. So for example, if you try to search for, say, equality, so then it gives you all the things for equality. Okay, so in this case, what we're interested in is modifying this body attribute. Okay, so what we'll do is find body. It turns out it exists here, world or body. So click on that. Remember, we specified the position. Just trying to see if we can find body, inertial joint, free joint, side, camera. See. Okay, so body, name, child class, mocap, pose. So this is the one we chose. Within body, we chose pose, and we gave the number 001. Now what we want to specify is the orientation. So we have actually a bunch of options for specifying orientation. We can use quaternions, axis angle, x-y axis, z-axis. Let's just use Euler. Euler basically gives you the Euler angles, and the convention followed by MuJoCo is what they call the XYZ orientation. So rotation about X first, then rotation about Y, and then rotation about Z. They're also known as Bryant angles if you want to search for it. So let's just do a simple rotation. We'll rotate this block about the Y-axis. So what we do is we go here, since this option body, this option is within body, we just put Euler here and then give it whatever we need. So 0, 0, 0 is the default one. If you want to change it by rotating 30 degrees about the y-axis, it will be 30, 0. Okay, so we made a change and we want to see what the change looks like. What we'll do is go back to the file and drop it. So you see it dropped at an angle of 30 degrees. Now you want to really be sure that this is 30 degrees about the y-axis. You don't see any axis in there. But what you can do here is if you scroll down right here and go to rendering, and if you go to frame, if you choose world frame and click it on, it will actually give you the world frame reference. So this blue is, so it's RGB. So R is X, or red is X, G is green is Y, and blue is Z. Say RGB, so right-hand system. So when we did this rotation, we did rotation 30 degrees about the y-axis. So it should be in this angle. So we can drop it again and check now if it's really 30 degrees about the y-axis. Okay, so that looks right. Okay, we can also flip it and do minus 30 and see what happens. Clearly drop the other way. Drop the other way. Okay, so now I knew that this is in degrees, but many times we're not working with degrees. We work with radians. We want to define everything in radians because that's the convention. So you can actually change the options here in this file such that everything, all the angles in this are in radians. And for that, what you need to do is you need to search for that right in the documentation. So if you go to the documentation, I will actually go right to the first summary. So it's a compiler. In fact, in the compiler, you should see angle. This angle can be specified to be degree or radian. So we can go down and search for compiler. Angle. So the default is degree. That's what we saw. 30 degrees was actually 30 degrees. And if you are using a URDF file, in which case this is a different way of writing files. It's in typically used for ROS. The default is radian. Anyway, here we want to specify this in radians, not in degrees. So what we do is we need to go and call compiler. So that's the attribute. So we'll put it here, compiler. And then we close the attribute. And then we need to specify now what option we want. So within compiler, there is angle. And then we want to specify it in degrees. So angle equal to radians. Okay. So if you specify radians, then we know that minus 30 degrees is the same as minus 0.5. Okay. So we should see no change. It should actually drop to the same angle. Yeah. So good point. You can also do reload. If you change the file, though, you might want to drop, or maybe that also works. Yeah, so there is a reload over here somewhere on the left side here. Yeah, it doesn't really work now because I modified the file. I presume that's why it didn't work. So let's just drop it now. Oh, there's an error. Invalid command. Let's see what error I did. Okay, I'm trying to debug this error. Oh, I know what the problem is. I did not saved it. No, that's right. Okay, the error is basically it's not radians, but it's radian. Okay, so if you put that, let's try doing the reload, see if it works. Nope. Euler does not have enough data. Okay, so I made a mistake here. So it should be minus 0.5. And so now let's just run this. Okay, now it works. So you can see that was specified as minus 0.5. It's actually 30 degrees. So that radian worked. Okay, let's move on. Okay, now one thing we want to do here is perhaps, things are really hard to watch because they fall fast. Let's make gravity slow down. So right now, default is, I think gravity is 9.81, but what if we slow it down to 1, and that way we can see things slowly. So now what we do is we try to see if there's an option called gravity inside here. So what I'll do is I just search for gravity. And it seems that there's an option available in option gravity. We can go ahead and check what this does. So option gravity. So you can see that the default is 0, 0, minus 9.81, but we want to specify 0, 0, maybe minus 1. So let's just change that. So gravity, sorry, my bad. So I need to first say it belongs to option. So option, then gravity equals 0, 0, minus 1. So that's going to slow things down by a factor of almost 10. Okay, so I saved it. And now I can just do, it fell down slowly. Okay, so sometimes, if you want to test something out, you can actually set gravity to 0 and then, use that. And I've tried that many times. It works great to debug code. Things are going slowly, and then it's much easier. Okay, so next, let's move on to things like how do you, this file, if you see carefully, the body of the cube or the box does not really have any mass inertia. How do you specify the mass inertia, right? So let's try to see how to do that. So this should probably be in body, right? Because body has to have a mass inertia. And let's just try to search for an option. So you can see within body, there's inertial. That one has a mass, quaternion, position. So these are the things I'm looking for. The position, perhaps. So that would be the center of mass. Quaternion would be the axis of that axis which you want to use, and then the mass and the inertia. So it could be diagonal inertia or full inertia. Diagonal inertia is it's the principal axis of inertia. It's only have 3 numbers, the diagonal elements. Full inertia would be have 6 numbers, which would be the fully populated inertia. It's not very important right now, but there's a difference between the two. So the way we do it is we need to specify it within body, because this was within body, and we'll specify inertial first. So inertial, which is within body, and you can actually paste it anywhere. You could put it right here if you want. It doesn't really matter. So within inertial, we want to specify a position. Okay, and I'm going to specify 0, 0, 0 because that would be midway of the cube. And then I need to specify a mass. Okay, and the default is SI units. So that should work. And then let's try to run this. Okay. So go ahead here, reload, and then it gives me an error. So mass inertia of moving bodies must be positive. This error actually corresponds to the fact that I defined the mass, but the inertia was not defined. It doesn't like that. So I need to specify inertia, one of the two, diagonal or full inertia. So I'll specify diag inertia, and that would be, put some very small number. It should be non-zero. Let's do this, and now reload. It fell, so it all worked fine. That's why it worked. Okay, now if you want to see the center of mass here, you can actually see it. There is center of mass, so it shows the center of mass right there. And then I said that this basically gives the center of mass. If you want to move it, let's say we want to move it along the z-axis. So let's move it to, so remember that the height of the cube is 0.3. So let's move it to top, right? So 0.3. So if this is right, then it should move to the top. So we can save that and then reload. You see it moved up, and it's a big walk. Okay. So let's go back to 0. Now, if you want to make things a little bit brighter, it's a little bit dark, then there is this element called visual. It's right on top. So we go back to the top of the file. Yeah, there. So there is an option called visual somewhere, visual. So if you want to change the the lighting, then what I recommend is using a headlight. So I'm going to, well, I'm just going to write the syntax here, but it basically follows the same recipe. You just go down, find what headlight is, find what these options are, and then you put the right thing here. So what I'm going to do is change this. So it needs visual, and then it needs its own section like we have for MuJoCo and world body. And within that, we want to put headlight, ambient, which is one of the options, equals 0.5, 0.5, 0. Okay, I think that will work. I can just put this in the chat. You can just copy paste it. Now if you go here and then reload, return. No, there's an error, line 5. Okay, what's the error? Oh yeah, I know. It's this probably. Okay, try reloading it. Okay, it's a little brighter. So let me just give you this command without errors. Okay, try copy pasting the second one I just sent in the chat. So you see it's much brighter. You can change that 0.5 to 0.1 to make it more dimmer. In fact, I think the default is 0.1, 0.1. Okay, so moving on, there's this thing which is very useful. It's called asset. It's like one way in which you can, I don't know if you know, but in C, well, in URDF, you have this thing called Zacros. Zacros are things where you specify, let's say radius equals 5, and then you can use R equals that R value in a bunch of places. That way you don't have to keep defining R. Also, you can change that value R equal to 2 and everything will be changed. So it's sort of a way of parameterizing things. So there's a way in which you can parameterize things in MuJoCo. It's by using this thing called asset, and it actually works very similar to visual. So you asset and then end it. Okay, and now what we'll do is we'll define our own material. Okay, we'll make the color of this this box as white. So we'll define our own material. So for that, what we have to do is we want to change the material. We'll give it a name. We'll call it white. And then when we say a material, we need to also define an RGBA value for it. That's how it's a given color. So RGBA for white is 1, 1, 1. Opacity is 1. And so that's it. Okay, once we do this, we need to change this color. Now this box is has this RGBA. So how do we actually use this white, change the color of the box to white? Now, I would like to not delete this because I want to keep it back. I just want to test something out. So in this case, what we want to learn is how to put a comment. So the way you put a comment in MuJoCo XML is you put exclamation hyphen hyphen. Okay, that starts the comment, and right here you do hyphen hyphen. So the comment actually is this hyphen dash dash. That's the beginning comment. That's how you put a comment. So what I'm going to do is take this, copy it because I need it, but I'm going to define no RGBA value for this. I'm just going to use white. So material, to do this. You just say material equal to, okay, let's see if this works. We'll go back. So it'll change this box to white if everything works fine. There it is. So changed it to white. I'm going to delete the center of mass. Okay, so that's an easy way of adding customization or parameterization by just using these asset class.
Professor, can you copy paste the comment in the comment box?
Sure. Here, just copy these things in that place of chom type equals box. Okay, so we just have 3 minutes before we end, but let me just show you how to create another object. Let's say we want to create another box, and we want to drop that box above this box. So let's first of all get rid of these axes. And then let's revert back to our old color. So remove the comment. Always check if it works. Okay, it works. Let's just get it back to 0. So where's minus 0.5 on this? Here it is, 0. 0. So it's going to drop vertically downwards. Okay, so now I have to create another box. Now within world body, I already have one body, this one. I need to create another body. So all I need to do is copy that down, just paste it below. Now, if I keep it as it is, then this box will be within the previous box. And I think there's collision properties are set, so they're going to do something really weird. So let's just change this position to, I don't know, let's change it to 2. Okay, that's the only change I made, and I hope this will work. Let's reload and see the 2 boxes. If you want to change the orientation of one box or change the color of that box, let's change it to blue box. So let's change this to 0.9 and 0. So it's a blue box. And then we'll change the orientation to be 90 degrees. So 90 degrees in radians is 1.57. And then reload it. Okay. Let's just do one more thing before we stop. Let me just put this at 1. Now, since it's a smaller box, I can just put it at 1.2, and I think this will work. Oh no, so if you saw this, then it's actually collided with that box. That's why it moved apart before it came together. So let's just make it a little bit higher up, 1.5. Okay, that works fine. Okay, now let's just put a sphere. Okay, so let's say how to create a sphere. The easiest thing is, and this is how I usually do it, is I just take code which works and copy paste it and then modify it. So let's look at how to put a sphere. So this is, if you see, this is an option in geom type. I need to change this perhaps to a sphere, but let's see if it exists here. So open the MGCF reference, go to geom, which I think is in body right here. And here, if you see, there is type, which in this case we chose box, but we want to choose a sphere. So let's just choose a sphere. Okay, so if you read through the sphere, you'll see that you need to change the size from 3 numbers, which define a box, to just a single number denoting the radius of the sphere. So just put let's say 0.1. Let's make it, I don't know, let's make it, I don't know what this color looks like, 0.5, 0.5, 0.5. Everything looks fine. We have to just move it slightly above. So let's move it at 1.7. And I hope it will work. So let's run. There it is. Okay, we can actually move it slightly to the right. So there'll be some interesting dynamics. So let's just move it in the y direction by let's say 0.2. Okay, and then if you want, let's move it slightly up 1 point. Okay, so reload. Okay, that well, we can move it slightly more to the left. Right, so 0.4. That's 0.3 is better. That's the width of the height of the geometry. So reload. Oh, that's not right. So I need to move it on the x-axis, I guess. So I couldn't quite see the axis. So it will be 0.3 here, 0 here, and now it will do what I wanted it to. Yeah, that's much better. Okay, so since we checked this out, now we can go back to turn on the gravity and reload. So that's how it will look in real world, right? Okay, so that's pretty much it. What I had to show
What
in
would
Excel.
happen if I put the gravity as positive?
Oh, it'll go
Just
flying there.
asking.
It'll just go flying there. So let's put, it'll go upwards. It's not interesting. I need to move the wall upwards, otherwise it won't be very interesting. Yeah, you can actually test it out very quickly by doing the simulation. So you need to write this file though.